Let's work through this example 1.3. At this stage, we are not algebraically solving for limits, so we're not finding them exactly, but we are graphically estimating them. So we're just getting an idea of what it means to take a limit. This function, we don't even have the definition of the function, we just have its graph. Let's estimate the limit of this function g of x as x approaches 4 different points in its domain. So let's think the limit as x approaches -7 of this function g of x. So if I go over here where x is equal to -7, and I think what is the function, what's the y value that the function is approaching, as I zoom in on that x is equal to -7, I see that from the left-hand side, the function seems to be approaching this y value. It looks like it's 6. But from the right-hand side, the function, when x approaches -7, this function looks like it's approaching, what's this y value? -3. So if the function approaches 2 different real numbers from either side, then the limit is not well defined. You don't have a real number there, so this does not exist. The limit does not exist in the case of jump discontinuities. So this one's done. Let's look at the limit as x approaches -3 of this function g of x. So where's x is equal to -3? That's where we have this vertical asymptote. So on the left-hand side, let me just switch colors. On the left-hand side, the function approaches -infinity, right? It decays, it gets smaller and smaller without bound. On the right-hand side, as x gets closer and closer to -3, it grows without bound. It approaches positive infinity. So this limit does not exist for 2 different reasons. One, the left-hand side and the right-hand side are not equal, but also positive and negative infinity are not real numbers. So this, again, is a does not exist situation. Our third limit, the limit of the function g of x as x approaches the value of 1. So as that approach x, as x approaches -1 in the domain, what is our function doing? Oh, sorry, not -1, +1. So over here, as x gets closer and closer to +1, what y value does the function approach? Here, the left-hand and the right-hand side of the graph both approach the same number. And that number seems like, let me zoom in there. What y value do I think this open circle happens at? Maybe 1, 2, -2.5, let's say. The limit is well defined because the function approaches the same value from the left and from the right, and that value is -2.5. All right, let's work on our last limit here. The limit as x approaches 3. So here's the x value of 3. What is my function doing as we get closer and closer to 3? This function has a well-defined limit. In fact, over here, we had a removable discontinuity. Here, we don't even have a discontinuity. It's a continuous function. The limit is well-defined. And it looks to me like it's approaching a value. Again, we're just going to graphically estimate. Maybe that's -2.75. Okay, so the limit exists if the left hand and the right hand give you the same real number.